My name is Dr. Kokat. In this video, we're going to be looking at filtering a solid after either a reaction or some sort of purification technique. So for that, we're going to need a funnel. There's many funnels we can use. So for example, we can use one of these porcelain funnels, which is called a Hirsch funnel. So you'll notice there's a filter paper, a tiny little filter paper on the inside that covers the holes that are at the bottom of the Hirsch funnel. We can use a Büchner funnel, so also porcelain. It has a filter paper that fits perfectly over the holes that the Büchner funnel has. We could use a glass funnel like this one, or even a plastic funnel like this one. For the glass and plastic funnels, we want to use a filter paper that has been folded over twice. So once like this, and then another time. Place that over the funnel, and then it'll cover the whole of the funnel. We can place any of these funnels on top of a filter flask. So a filter flask looks just like an Erlenmeyer flask, except it has a sidearm. So if we place a neoprene adapter, and then let's say the Büchner funnel on top, we can now filter anything through there if we wish. This would be gravity filtration. It takes a little bit longer. So if you're impatient like me, you probably want to use vacuum filtration instead. So for that, we're going to need a vacuum source. So we want to attach this hose to our sidearm. And the other end of the hose is connected to a vacuum source, in this case a vacuum pump which is located in the basement of our building. Other universities will have an aspirator system, which is essentially just using a faucet, the water running through the faucet, and an adapter like this. So it can be made out of plastic or metal. And this part would connect to the faucet. As you turn on the water runs straight down, and that creates a vacuum on the sidearm here. So you will connect the hose, such as this one, to our filter flask, and then as the water runs, it creates a vacuum. So this is very inexpensive. You just simply need a faucet to run it. The disadvantage is if the water pressure in the building changes, they'll vary the pressure of your filtration system. For this demonstration, we're going to be filtering benzoic acid, which is found already in this test tube. And we're going to be using ice cold water, so I pre-cooled it in an ice bath. And if we place a little bit of that water in our benzoic acid, you'll notice it doesn't really dissolve it. So you want to use, obviously, a solvent that doesn't dissolve whatever you're trying to filter. If the solvent is cold, it'll have less of a chance of dissolving the compound. So at this point, we want to pour the contents out into our filtration system. But before we do that, we want to turn on our vacuum. So you'll hear that sound. That's pressure, a vacuum that's being created through our system. A good idea is always to wet that filter paper, let some water go through. It allows the filter paper to stick to the funnel better. There'll be less holes for the solid to sort of sneak through and into the bottom of the filter paper, filter flask, which we don't want. At this point, you want to sort of stir this and pour it and tap out as much as you can. Let it run for a few minutes. It'll get the water through the filter paper, and then after a few minutes, you should just simply have a solid at the top of that system. So right on the filter paper, we should have a fairly dry solid. So if we really want to dry, we want to let this run for at least 30 minutes. Or otherwise, we could just place it in a drawer, let the solid cool perhaps for a day or two. So depending on the solvent, if it's more volatile, it'll take less time. If it's a solvent with a high boiling point, you want to let it dry for a lot longer.